Our last video, it's on your last page of notes. We're going to look at one other strategy that allows you to find limits, and that strategy is called the squeeze theorem. And I'll explain how to use that squeeze theorem, but let me state the theorem first. So it says if h of x is less than or equal to f of x, less than or equal to g of x, for all x in the open interval containing c, with the exception of possibly that one c itself, and if you know the limit as x approaches c of h of x equals L, and that also equals the limit as x approaches c of g of x, then the limit as x approaches c of f of x exists and is equal to L. So the way that this would work, I've written in red for you that the first thing that has to be true is the f of x has to be in between h of x and g of x. And probably the best way to do that, would to know that happens, is to look at the graph, that f of x has to be squeezed in between the two other graphs, h of x and g of x. And then once that condition is held, you should find whatever limit you're being asked to find for h of x. And so if you find that limit and that limit turns out to be L, then you should go find the limit for that same c value and do g of x. So the limit as x approaches c for g of x, if that also turns out to be L, then you've met all the conditions of the theorem. So your conclusion then could be that the limit as x approaches c of f of x is also L. So that would be the way to work with the squeeze theorem. Now, because the squeeze theorem is true, that lets us have two special trig limits that I will want you to memorize. And they're just going to kind of come up out of the blue. So you're going to have to remember these. So this is the limit as x approaches 0 of the sine of x over x. And that limit is 1. Now, one way that I remember that is the I in sine looks like a 1, and so I remember that limit is 1. And I might also go ahead and add to this, the reciprocal is also true, and that'll come up in your homework. So the limit as x approaches 0 of x over the sine of x is also equal to 1. And the second limit that comes up because of the squeeze theorem is the limit as x approaches 0 of 1 minus the cosine of x over x. That limit equals 0. And again, I remember that one because the cosine has an O in it, and the O looks like a 0. The reciprocal of that is also true. So the limit as x approaches 0 of x over 1 minus the cosine of x is equal to 0. One thing I'll point out about these theorems, and this is going to be your key to working with them, is to look at the fact that the angle is the exact same expression as the denominator. If that is the case, then the theorem holds. So the angle of your trig function has to be exactly the same as your denominator, and that's true in both cases. Now, just because I circled those does not mean they can be canceled. That angle on your trig function is connected to that trig function and cannot be canceled away. I only circled them to have you take note of them. Our final example then is the limit as t approaches 0 of the sine of 3t over 2t. Well, we want to do direct substitution, so we'll put in 0 in place of the 2t's and look to see what happens. That would give us sine of 3 times 0 over 2 times 0. Well, that would be the sine of 0 over 0. The sine of 0, if you remember from our earlier example, 0 in your unit circle is at this ordered pair, and the sine is the y value. So that would be 0, and then your denominator is 0, and this is indeterminate. Which means we have to try a different strategy. Well, neither of the two strategies that I talked about in previous videos works for this. It's not a polynomial, so we can't factor. It's not a radical, so we can't rationalize anything. So the only other strategy that you have is to see, does it somehow fit one of those two special theorems? Well, it involves sine, but my angles are not exactly the same. In the numerator, I have 3t, and in my denominator, I have 2t. So I have to work to make my denominator match that angle of 3t. And this is the work that is going to take place. We're going to do the limit as t approaches 0, and that's important for those theorems to hold true. The limit has to be a value approaching 0. I need to work on 2t so that I turn it into 3t. Well, if we were in class, I would be making you think about this, and maybe you could stop the video and try to think, what could you multiply by 2t to make it become 3t? And hopefully you'll think of a fraction. You could multiply by 3/2. But you know that if you do something to the denominator, you must also multiply that same amount into the numerator. So I'm going to be multiplying by 3/2. Now notice that I'm not doing anything to the angle. The angle has to stay 3t. So you're working with the denominator. What can you do to the denominator? So now we'll do our work here. We have the limit as t approaches 0 of 3/2 times the sine of 3t over, and then we have 3/2 times 2t, and that is 3t. So now I'm going to separate this out. I'm doing the limit as t approaches 0 of 3/2, and I want to multiply that by the limit as t approaches 0 of the rest of that problem, which is the sine of 3t over 3t. And this will actually tie into our very first video. We said that if you do the limit of a constant, that your answer is just the constant. And that's what we have going on here. The limit as t approaches 0 of 3/2 is 3/2. And then this part of the product, the limit as t approaches 0 of the sine of 3t over 3t, is an application of the special trig limit that we introduced earlier in this video. And that limit, it has a sign, which is an I, which looks like a 1, and that limit is 1. We can multiply those two limits together. 3/2 times 1 gives us 3/2. And so therefore, the limit as t approaches 0 of the sine of 3t over 2t equals 3/2. So your assignment is a little long this time, but many of the problems are just direct substitution and not much work to show. You will have some where you are doing the different strategies. So good luck, and I will be looking forward to working with you on these.